Engineering. Today we are here to discuss on the course Advanced Design of Concrete Structure. So first of all we discuss the objectives, broader objectives of the course. First is identify the provisions made in IS 456-2000, IS 3370-1984 and IS 1346. Second objective is develop the concept of inline theory. And third objective is analysis and design of different RCC structural elements, water tanks and retaining walls. Now this is the lesson number 3. In the lesson number 1 and 2 we have discussed the introduction of flat slab, advantages, disadvantages of flat slab, then method of analysis, that is direct design method, and second is equivalent frame method. Now in this lesson we have discussed the design procedure of internal panel of flat slab. So objective related to that lesson is analysis and design of RCC element such as flat slab. So now we see the total design procedure, stepwise design procedure of internal panel. So first step is always write down the given data or data which is given in the problem, that is longer span of the slab, shorter span of the slab, grade of concrete, grade of steel, loads on slab and etc. Column sizes, column height, etc, etc, etc. Then secondly, calculate the width of column strip and width of middle strip. So how to calculate the width of column strip along longer direction, which is denoted by LCX, is equal to 0.25 to 0.50 L. Now any factor between 0.25 to 0.50 you can select, multiplied by another direction length, that is L2, we get the LCX. Then calculate LCY, that is width of column strip along shorter direction. So again the factor is same, 0.25 to 0.50. So you can select any factor from that 0.25 to 50. But what is a basic rule? So you cannot LCY should be less than or equal to LCX. So to simplify the calculation, always remember that keep the LCY is equal to LCX, so that the calculations, some part of calculations are easier. Then calculate the width of middle strip along shorter direction and longer direction, that is LMX and LMY. Next and most important steps henceforward, first is calculate the effective depth provided. So again in that there are two cases, if the slab is provided with drop or without drop. So case 1, if the slab is provided with drop, then the formula of D provided is equal to L by D, L by ratio. So for mild steel grade, if you use the mild steel grade or if the given grade of steel is mild steel, then the equation is D provided is equal to L1 upon 40. Always remember that for this step you want to consider the longer span of the slab. So L1 upon 40. If the higher grade steel or HYSD bars are used or given, then D provided is equal to L1 upon 32. From this equation you get the value of D provided. Now you want to calculate the overall depth of the slab, that is capital D. So capital D provided plus effective cover plus depth of the drop, which is assumed. Now how it is assumed we will discuss in the in later steps, but here remember that if you calculate the overall depth and if the slab is provided with drop, then D is equal to capital D, overall depth of the slab is equal to D provided plus effective cover plus depth of drop. Now what is the second case? Second case is flat slab without drop. Now if the slab is without drop, then for mild steel the equation is D provided is equal to L1 upon 40 into 0.9, means you are going to reduce the 40 value or 40 ratio by 10%. And for if higher grade steel is used, then the equation is D provided is equal to L1 upon 32 into 0.9. Again overall depth is equal to D provided plus effective cover. Now here the depth of drop is not considered because the slab is without drop. Hence, the depth of drop is not considered. Now, this is how you can calculate the effective depth provided. Next step is calculate the loads on the slab. So, first of all, self weight, you know that overall depth of the slab multiplied by density of concrete. The density of concrete is 25 if not mentioned in the problem. Then live load as per the given data, or you want to calculate the live load by using IS 875 part 2. Finish load again same, if the problem if they mention that finish load in the problem, you want to take that finish load, or you want to calculate that finish load from the IS 875 part 2. Then calculate the total load WD. Then calculate the total load WD, make it factor by multiplication factor 1.5, that is Wn, and then the total load on the slab is equal to W naught is equal to Wn into L1 into L2. The Wn is factored load, L1 is the longer span, L2 is the shorter span, and the multiplication of these three is nothing but the total load on the slab. Next important step, again moment calculations. So, again in that moment you want to calculate the moment in both direction. First L1 direction, that is in longer direction, second L2 direction, that is in shorter direction. If the slab is given slab is square slab, then you may calculate only you may calculate the moment in only one direction and use the same moments in the another direction, because the given slab is square slab, means the L1 is equal to L2. Hence, whatever moment you have calculated for L1 direction, the same moment you can use for the L2 directions. So, your work is reduced if the slab is square slab. If the rectangular slab is given, then you want to follow this procedure. First, calculate the moment along L1 direction, which is denoted by MO1, which is equal to MO1 is equal to W naught, that is total load on the slab, multiplied by L1 divided by 8. Now, this MO1 is the total moment acting on the slab. Now, first you want to divide that total moment into positive moment and negative moment. Now, as we discussed in the introduction, the out of total moment, the 35% moment is act as a positive moment and 65% moment is act as a negative moment. So, M naught 1 into 0.35 is the positive moment, which is denoted by MP1, and MO1 into 0.65, it is known as negative moment, which is denoted by MN1. Now, you want to distribute that moments into column strip as well as into middle strips. So, this is the table which is given in the step, that is distribution of moment into column and middle strip. So, how to distribute? First column is moment, second column is column strip, and third column is middle strip. So, first row negative moment. So, negative moment is Mn1. So, out of that Mn1, 70% negative moment is carried by the column strip, whereas 25% moment is carried by the middle strip. So, same distribution is done here, 75% into Mn1 is M1, that is negative moment in a column strip, then negative moment in the middle strip is denoted by M2, which is equal to negative moment into 0.25. So, 25% is acting in the middle strip and 75% is acting in the column strip. Second row is positive moment. You want to distribute the positive moment into column strip and middle strip. So, as we discussed earlier, out of the total positive moment, 60% positive moment is carried by the column strip, whereas 40% moment is carried by the middle strip. So, same distribution is done here. M3, that is positive moment in column strip, which is equal to positive moment into 60%, and M4 positive moment into 40%. Next, B part, you want to calculate the moment along L2 direction. If the slab is rectangular slab, the procedure is same. First of all, calculate the total moment, then positive moment, then negative moment, and then again distribute that positive and negative moment into column strips and middle strip. So out of total moment, positive moment is 30%, 35%, negative moment is 65%, and distribution, when you distribute that moments into column and middle strip, negative moment 75% negative moment is carried by column, 25% carried by middle strip. Whereas for positive moment, so 60% positive moment is carried by the column strip, whereas 40% is carried by the middle strip. After moment calculation, you get the 8 moments. So out of that 8 moments, for checking of the effective depth, you want to consider the maximum positive moment and also maximum negative moment out of the tables, which is calculated in the step number 4 A and step number 4 B, that is positive moment or negative, positive and negative moment from table number 4 A and 4 B. So equate that maximum moments with MUR max. MUR max, what is MUR max? 0.133 FCK BD square, 0.138 FCK BD square, 0.148 FCK BD square, which are the formulas are given in IS 456-2000. According to that formula, you want to calculate the D required. And what is the checking condition? D required should be less than D provided. D required, which is calculated in the above step. So D required should be less than D provided. If you satisfy the condition, then go for the next step. If you don't satisfy that condition, then redesign the slab from the step number 2. Next most important step is check for shear. So for check for shear, there are some steps you want to follow. First is calculate the width of the critical section. Width of critical section is what? dt is equal to column size plus d by 2 plus d by 2. So d is nothing but the overall depth of the slab. Then calculate shear resist by the critical section. Vu is equal to total load on the slab minus load carried out by the critical section. So that is Wn into 2 into dt. Then calculate nominal shear stress tau v. Tau v is equal to Vu into B into D. Then shear stress in concrete tau c is equal to 0.25 under square root FCK. So what is the checking condition? Sorry. If tau v is less than tau c, then your design is safe, and if tau v is greater than tau c, you want to redesign the session. If you satisfy the two conditions, that is depth required and second is shear check, if you satisfy these two, then move forward for the reinforcement calculations. So again, in that reinforcement calculation, you want to calculate the steel for column strip and middle strip. Again, for column strip, negative steel and positive steel. So we see one by one. First, A longer direction steel, column strip. Area of reinforcement in longer direction in column strip. Again, in that, first calculate the negative reinforcement required in column strip. So your formula is AST negative is equal to 0.5 FCK BD FCK upon FY into bracket 1 minus under square root 1 minus 4.6 into M1 upon FCK BD square bracket complete B into D. The formula is unique formula, which is already used in slab and beam calculations in DCS 1. Only remember that you want to check the moment M1 and B, means if you calculate the steel for column strip, right,